This is another fluid pressure practice problem for exam 4, also for the final exam. And again, I work it several different ways. I use the resultant of the pressure distribution. We use F is equal to gamma Z bar A, and we use the horizontal and vertical method where applicable. So lots of different ways. So this is a plate slants away from the water for a section and then drops vertically for a section. This slanted section is a 3, 4, 5 slope. So he's 5 meters long. He's 4 meters deep. And then this vertical section is 6 meters deep. And this dam or this gate is 4 meters wide. This is fresh water, so gamma is 9810 newtons per cubic meter. We're going to find the resultant force up here on AB, and we're going to find the resultant force down here on BC. So on AB, you can draw a pressure distribution along AB. The pressure distribution acts perpendicular to AB, so it's 5 meters long. The pressure at the bottom at B is equal to the depth, which is 4. Even though the plate is 5 meters long, the depth is 4. And so the pressure here is 4 gamma, and it acts perpendicular to this plate. The FR is 1/2 of base times height times the width into the board. So 1/2, the base here is 4 gamma. The length of this triangle is 5. The width into the board is 4. And so this resultant force is 392.4 kilonewtons, and it acts at a 3, 4, 5 slope. And that's the volume of the pressure distribution. If we use the FR is equal to gamma Z bar A formula, sometimes I call this the Gaza or the Giza formula for GZA. Again, the plate is 5 meters long at a 3, 4, 5 slope. The midpoint of the plate, the Z bar, is 2 meters deep. So Z bar is 2. The area is 5 times 4, which is 20. And gamma is 9810. So the FR is equal to 9810 times Z bar, which is 2, times the area, which is 20, and our FR is 392.4 kilonewtons. Again, acts perpendicular to the plate, so it's at a 3, 4, 5 slope. Pretty easy. Not hard, it's pretty easy, isn't it? Let's work it a third way. So a third way, so now that this guy slants kind of away from the water, then there's water above this plate that is occluded or that is displaced. And so we can work this with horizontal and vertical. So the horizontal is the vertical cross-section of this area, which is basically 4 meters. The vertical force is an upward force, or a buoyant force, if you will. And so there's an upward force that acts on this plate that's equal to the weight of the water that is displaced by this plate. And so this is 3 by 4. So the volume is 1/2 of 3 times 4 times 4 into the board times gamma. And so the F vertical is 24 gamma, which is 235.4 kilonewtons upward. The F horizontal is 1/2 base times height times the width into the board. So 1/2, the base is 4 gamma, the height is 4, the width into the board is 4, and so my F horizontal is 313.9 kilonewtons. Finally, my resultant force is 313.9 I plus 235.4 J kilonewtons. And you put this as a vector in polar form, you get 392.4 kilonewtons at a 3, 4, 5 slope, which is basically what we got from the other methods. All 3 methods work. All 3 methods are valid. You should know all 3 methods. In the test, use whatever's easiest for you. Use what you can see. Use what you understand. It's pretty clear that the Giza method is actually pretty easy. But the pressure distribution, I think, is also valid because at least the FR, it gives you the location of FR, which is the center of the pressure distribution. One of the weaknesses of the gamma Z bar A formula is it doesn't necessarily give you the location of FR. You have to kind of get that from the pressure distribution. But so the lower part of the wall, we get to the lower part of the wall from B to C. So B to C is submerged. And so the pressure distribution on BC is a trapezoid. Point B is 4 meters deep. And so the pressure at B is 4 gamma. Point C is 10 meters deep, 4 plus 6. The pressure there is 10 gamma. And so FR on this vertical section is the area of the trapezoid, which is 1/2 of 4 gamma plus 10 gamma, times the length of the plate, which is 6, times the width into the board, which is 4. And so the FR is 1648 kilonewtons, or 1.648 meganewtons. 1.648 times 10 to the 6th newtons. We can use the gamma Z bar A formula. And so for this vertical section, the Z bar is the middle of this plate, which is 4 plus 3, so Z bar is 7. The area of this plate is 6 high times 4 into the board, which is 24. My gamma is 9810. So my FR is 1.648 meganewtons, same number we got up here. And we cannot use the horizontal and vertical method on this per se. In a way we do, because basically our FR is our F horizontal, the F vertical is 0. So we kind of use it, we kind of don't use it. So again, these are 2 different problems worked 5 different ways.